Hey everybody, hope you enjoyed your week off. Right back at it here, starting the third quarter, which is exciting. That means we're on the home stretch, right? On the way back down the hill. So I think we have like 77 more days of school. You guys have lots to learn still. We're going to start with talking about systems of equations. That's unit 5 for us. And so systems of equations are kind of like solving we solved earlier in the year when we solved for like a two-step equation or something like that. But now we have two equations with two unknown variables. It's kind of crazy. It would look something like y equals 6x minus 3 and y equals 2x plus 15. And sometimes there's little curly brackets around it like this. But basically they want you to see that these two equations go together, and they want you to actually solve for a solution. So we're going to start off today with what's called inspection. We're just going to kind of talk about what we're looking at, what we're looking for, most importantly, I guess, and some things about some special cases, just like we did when we solved equations. So, first off, when we have these equations, right, these are linear equations. Notice they're in slope-intercept form right now. All the ones that we look at are either going to be in slope-intercept form, or you could rewrite them in slope-intercept form. So all of those steps, when we talk about linear stuff, we're still dealing with the same stuff, just like we were when we did lines of best fit. So it's still, still going together. And what we're looking at here is two lines. I have this line and I have this line. And when we're solving an equation, a system of equations, what we're looking for is the answer to this problem is going to be the point where these two lines cross each other. Right? So somewhere these two lines may intersect each other. That exact point is the solution here. The x value and the y value. So our answer could be something like 4, -2. Right? Maybe that's where those two lines cross each other. Our answer is going to look like this, as an ordered pair. It's a point. It's where these two lines intersect. So we're not going to actually solve any today, but we want to be able to talk about how many solutions we can expect from something. And so, if you remember back to when we solved stuff that looked like this, 3x plus 11 equals 3x plus 17, right? And we were solving equations. We want to solve it for x. Hopefully you remember all this, right? We know that if there's variables on both sides, I'd want to get rid of a variable, so maybe I'd subtract this 3x. But what happened when I subtracted that 3x was those canceled out and those canceled out, and we were left with 11 equals 17. And that was not a true statement. My variables are all gone, and we called this a special case, right? And since my variables are all gone, we know that this one meant no solution because we had different numbers. Well, really what we do when we are doing that, when we solve this problem, is this is kind of like a system of equations. This would be one side, that's one equation. This would be another one, that's another equation. And so I'm going to kind of show you some little tricks, I guess, to kind of talk about what we can expect if our lines are going to cross, how will they cross, what that's going to look like. So, first things first. There are three options that can happen here. The first one. Okay? If this was my system of equations, notice they're both in slope-intercept form. That's going to make it nice for us. If they're not in slope-intercept form, we have a little bit of work to do on the top here. We might have to rewrite it. Hopefully you guys remember how to do that, right? Maybe we'll do one just to remember. But I notice here that my slope is the same in both of these. You guys see that? So my m, my slope value, is the same. So this situation I'd call same slope. But if I look over here at their y-intercepts, those are definitely different numbers. So they have the same slope, but they have different y-intercepts. And there's this really cool thing about slope. I can show you real quick. I know the smartboard's not great to see on camera. But if I graph that first one, starts at -2, goes up 1, 2, 3, 4 over 1. Looks like that. 1, 2, 3, 4. Okay. Real steep, right? So that was the first equation. If I graph the second one, it starts at 6. And it goes 1, 2, 3, 4 over 1. If you take a look at these two lines, what you should be able to see is that these lines are actually parallel lines, which is really interesting here. So when we talk about where two lines are going to cross, because that's the solution we're looking for, right? Where are these two lines going to cross? Well, in this case in particular, they are not going to cross. Yeah. So if we see the same slope but different y-intercepts, this is going to be our no solution case. Every single time the slopes are the same but the y-intercepts are different, we know that is going to be a no solution. So today we're not really going to solve anything. I'm not going to teach you a method in solving, but I'm going to say if you see that the slopes are the same but the y-intercepts are different, you need to know that means no solution. Okay? Now, I said that there was three possibilities here, right? What if we have the same slope and the same y-intercept? This marker is worse than that marker. Third time's the charm, let's see. So let's say we have, y equals 5x plus 9. And, I forgot I was going to show you that. So let's do 2y minus 18 equals 10x. All right, now notice, I know the slope and the y-intercept in this top one, but I do not know the slope or the y-intercept in this bottom one because it's not in slope-intercept form, right? So what I need to do first is to rewrite this bottom equation in the slope-intercept form. So if you don't remember how to do that, remember we always want to get y by itself. So we're just going to solve it. I'm going to add 18 to both sides. 10x and 18, remember, not like terms, so we can't add them together. We just leave it. 10x plus 18. And then, if I divide by 2 to get rid of the 2 here, now it's in the slope-intercept form because y is by itself. 10x divided by 2 is 5x, and 18 divided by 2 is 9. And now if you look at our two equations, you notice that the slopes are the same, but the y-intercepts are also the same. So essentially, this is the same line, right? This is like the same line on top of the same line. So this one is going to be our infinite solutions. If the slopes are the same and the y-intercepts are also the same, that's going to be our infinite solutions case because those lines are exactly the same line. So those are two options. Same slope, same y-intercept, that's going to mean infinite solutions. Same slope, different y-intercepts, that's going to mean no solution. So the third option then, if you're following me here, is I could have different slopes. Okay? And so if I have two things with different slopes, y equals 2/3 x minus 7, and y equals negative 4x plus 1. All right, we're not going to talk specifics today. We're going to get there later this week about how we can actually solve this thing. But what I want you to see is that if they have different slopes, there's going to be one solution. There is some point where these two lines are going to cross. If the slopes are different, the lines have to cross. So, for tonight's homework, all you're doing is saying how many solutions you think it has. Is it infinite? Is it no solution? Is it one solution? And some of them you're going to have to kind of just change in the slope-intercept form. That's really going to be the only math you'll have to do. But this idea is going to be very important because when we start solving them tomorrow and looking at the three ways that we can solve systems, these are all really, really important ideas behind that. Knowing that they're going to cross if the slopes are different, and if the slopes are the same, knowing that we have to have one of our special cases. All right, cool. Yeah, your homework's in your workbook or something, I think. Yeah, I'll see you guys later.